This is CPM Precalculus Chapter 3, number 44. So here we're given two graphs. We have g of x here, and we have f of x here. And we're told g of x is a transformation of f of x. That means we start at f of x and we get to g of x after we've gone through transformations. So then we're asked to give an expression for g of x in terms of f of x, right? So that means we want to have g of x equals something, and f of x is here related somehow, right? Because it's just a bunch of transformations. So how do we do this problem? Well, one way to look at this problem is to look at the different types of transformations we know and to see which ones has the graph gone through. So the best way to do this is to look at reflections, right? This can be across the x-axis or the y-axis, vertical stretches, horizontal stretches, shifts. So let's call that vertical shifts, right? Vertical translations, and horizontal shifts, okay? And we want to look at these transformations in this order, okay? So start here and actually examine the graph. Has it gone through transformations? If it has, then go ahead and apply them, right? And then go ahead and continue on. So reflections, do we see a reflection taking place? Is it reflecting across the x-axis and then it's kind of like backwards like this? No. How about reflecting across the y-axis and it's over here, something like this? Again, no. So let's go ahead and just rule this out. I'm gonna let's use just blue. So none obvious. How about vertical stretches? So vertical stretches, you have to look at vertical distances. So luckily we have more than just the straight line. We have we have this section here, it goes down, it goes up again, right? So what is the distance between this line and this line that it goes down to? So that distance here is 1, 2, 3 units, right? And what about this distance from this line to this line that it goes down to in this graph? Well, that's 1, 2, 3, 4, 5, 6 units, right? So what happened? We went from 3 to 6. That's a vertical stretch, right? That's stretching it a factor of 2 times. So we do have a vertical stretch, right? I'm going to erase this so it's not in the way. But we do have a vertical stretch, and we have a by a factor of 2, right? So let's go ahead and draw that in, and also label how that's going to be written. Because if we start at f of x, stretching it vertically by a factor of 2, remember, it just means to go ahead and place a 2 in front of f of x. And let's draw that in green. Okay, if we stretch vertically, we're multiplying every y value times 2. So the y value here is negative 1. Negative 1 times 2 is negative 2, so it becomes negative 2. The y value here is positive 2. If we multiply that by 2, we get 4. Positive 2, we get 4. So all these are 4 to the left and 4 to the right. And these connect in a straight line here, right? So that here in green is 2 times f of x. It's our vertical stretch, right? So then let's start with the green graph and ask our question, are there any horizontal stretches? Well, luckily for us again, we have this region horizontally that we can see the difference of. And there's 1, 2, 3, 4, 5, 6 units going that way. Or here we have this region and we have 1, 2, 3, 4, 5, 6 units that way too. So we have 6 here and 6 here. So that means that right now I'm going to say there are not any horizontal stretches or strings taking place because there hasn't been a change in the width of that region. So I'm going to cross this out, okay? So finally, let's go to shifting. So vertical shifts, okay, has from the green graph to the one in black, are there any shifts vertically? So we start here, the point here in green is 2, negative 2, and this one over here is 1, 0. So vertically, it went up 2 units, right? To get to there, so starting here, it has to go up 2 units. It's also going to go left 1 unit. So I can see, yes, there is a vertical shift, and that's going to be up 2 units, right? At the same time, I can see the horizontal shift, yes, and that's left 1 unit, okay? So let's write this down. The equation for up 2 units is just going to take f of x, right? So let's start with 2 times f of x. And if we go up 2 units, that's just going to add 2 outside the parentheses. Left 1 unit, we're going to start what we have up here. I'm going to leave a space here because inside the parentheses, left 1 unit means to add 1 here, right? That means left 1, right? So this is going to be our final expression for g of x. So I can even write that here, g of x is equal to 2 times f of x plus 1 quantity plus 2, okay? So let's go ahead and check this. So to check this, let's actually have the graph in green shift up 2 and left 1. Okay, so if I shift every point up 2 units and left 1, that's going to put this point here. Left 2, up 1, puts that point here. Left 2, up 1, puts that point here. So do we have our g of x here in pink is the question, right? And did I draw this right? No, I didn't. So, sorry, it's only left 1 unit. That's what I did wrong. It's up 2. So it should be up 2, left 1. That's where I made a mistake. Left, or up 2, left 1. Here we go. Yeah, because it should appear to be the same. If you don't get it the same, go ahead and check your work just like I kind of did. Because we know that if we look at it now, yes, they match, right? This point here is -2, 5, and this point here is 1, 2, 5, 2, -2, 5. This point is 1, 0. This point is also 1, 0. This point over here is 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 here, right? 1, 2, 3, 4, 5, 6. Excuse me. So wait, is this 1, 2, 3, 4, 5? This is 6 up as well. Right, let's check this one. 1, 2, 3, 4, 5, 6. Oh, I was counting wrong. So this right here, we also know is starting at 0, 0, 1, 2, 3, 4, 6. And this one is also 1, 2, 3, 4, 6. Yes. Okay, so we know they match. We checked their answer. We figured it out by doing these 3 transformations. We skipped 2 types of transformations because we noticed that none took place. And this then is our final answer. Okay, so that's going to end for us CPM Precalculus Chapter 3, number 44.